Hello everyone. So today I'm going to talk to you about the sine rule. Now the sine rule is one of our basic rules in trigonometry. What's really valuable about the sine rule though is that it works for any triangle. You can see in this example here, it isn't just right angle triangles. So if you are looking at a question and it's not right angled, then you know you can't use Pythagoras or SOHCAHTOA. So this is another great option to look at, and it might be able to help you solve that question. So the sine rule is written out over here to the side. It says A divided by sine A. So a side divided by the opposite angle is going to give you a ratio that's equal to B divided by sine of B. So again, B divided by the sine of its opposite angle, which will equal to C, the other side, divided by the sine of its opposite angle. So it's really important here to remember that it's always a side divided by the sine of the opposite angle. A being opposite from the angle A, B being opposite from the angle B, and C being opposite from the angle C. Normally write the sides in lowercase and the angles in uppercase, just to make that distinction clear. Now you can use this again not for a right angle triangle, but you can use it for them too. You can use it for any type of triangle, and you can use it to find either a side length or an angle size. So we're going to look now at an example of a question that wants us to find a missing side. So again, this triangle here is not right angled, so we know we can't use Pythagoras or SOHCAHTOA. So the sine rule is a pretty good idea, a pretty good place to start with. So if we look at what we have here, our missing side that we're trying to find, we do know the opposite angle, and then we have another side here, but we actually don't know the opposite angle there. So what might be useful to do first of all is to try and fill in whatever information we can find out, and that would be the missing angle here. So knowing that all angles add up to 180 degrees, that tells us that this angle that we're missing must be 50 degrees in here. So now it looks like we are in a position to use the sine rule, because we have an unknown side here, but we know its opposite angle, and we have another known side where we know the opposite angle. So I'll show you an equation that we can make now that we can solve for x, and it'll give us our answer. So the first thing we always do is rewrite out our formula. Again, if you're not sure of the formula, you can look it up in trigonometry in the log tables. I think it's page 16. So we can say A divided by sine A is equal to B divided by the sine of its opposite angle. Now we could put in C there if we wanted to, but we actually only need to fill in two of these in order to get a workable equation. So we can put in x as one of those sides, should be divided by its opposite angle. So x divided by the sine of 75 should be equal to 11 divided by the sine of its opposite angle, 50. Now, what we have here is an equation. So we have an equal sign and we have only one unknown. 11, sine 75, sine 50. We can all figure out what their values are. So that means we can actually figure out what the true value of x is then if we follow this equation through and try and solve it out. Let's start filling this in now. So x stays the same. The sine of 75 degrees is 0.966. Over on the right hand side, 11 stays the same, and the sine of 50 is 0.766. Now we know from experience that if we have two fractions on either side of an equals, we can cross multiply to get our answer. So if we do that, it will be x times 0.766, so 0.766x, and then 11 times 0.977, sorry, 0.966. So on the left hand side we stay with 0.766x. On the right hand side that gives us 10.626. And then just to solve finally for x, we're going to divide both sides by 0.766. On the left hand side that will cancel out and we'll just get x. On the right hand side that works out to 13.872, and it's actually a longer decimal. I'm going to leave it at 3 decimal places. But if you were given that question in an exam, you would just make sure that you check to see if it's two decimal places or 3 decimal places or the nearest centimeter. Okay, so now we'll have a look at one more example. In this example, you're being asked to find an angle theta. You're given two sides and you're given another angle. So again, straight away looking at this triangle, you would realize that you're not told that it's a right angle triangle. So you know you can't use your normal tricks like Pythagoras and SOHCAHTOA. So this looks like we can use the sine rule because we have a side, the opposite angle missing, and we also have a side where we know the opposite angle. So we'll write out the sine rule as a divided by sine A is equal to b divided by sine of b. Again, the sides are small and the angles are big. So we can start filling in what we know now. A we can put in as 15.2 divided by the sine of its opposite side. So that's divided by the sine of theta. It's going to be equal to b, which is 11.5, divided by the sine of its opposite angle, which is 40 degrees. So again, we're in a pretty good position to solve this because we have one unknown, which is theta, and we have an equal sign. So we know 15.2, we know 11.5, and we can figure out what the sine of 40 is. So we really only have one unknown and it equals, so that means we know we can solve it out. Let's start simplifying this a little bit. We'll just get the sine of 40 degrees. So the rest of it just stays the same for now. 15.2 divided by the sine of theta is equal to 11.5 divided by the sine of 40. Sorry, simplifying the sine of 40. So that actually is going to be 0.643. Now again, we have two fractions on either side of an equals, so we can cross multiply, and that gives us 11.5 times the sine of theta is equal to 15.2 times 0.643. So we'll multiply that out now. 15.2 times 0.643 will give you 9.774. And on the left hand side, 11.5 times the sine of theta. We can't figure out yet because we actually don't know it. So we want to get rid of the 11.5. So the way we do that is divide both sides by 11.5. That will cancel on the left, so we get sine theta on the left. And on the right hand side, we get 0.85. Now you'll remember from SOHCAHTOA, if we have a sine of an angle, if we just want to get the angle by itself, then we have to get the sine inverse of that side. So we're going to get the sine inverse of sine theta, and then we have to get the sine inverse of the opposite side too. So the sine inverse and sine cancel, which means that we're just getting the angle now, which is what we want. And then we figure out the sine inverse of 0.85. That gives us 58.2 degrees. Okay, I think you're ready to have a go at a few questions now. Just make sure you've taken down your examples so you have them to look back on as you're going through.